Okay, today we're going to look at the fair division chapter. So, things to keep in mind. Fair division method is procedures that can be followed that will result in a division of items in a way so that each party feels they have received their fair share. For these methods to work, we have to make a few assumptions. Now, remember, we're talking each party feels they have received their fair share. Not each party receives an equal share. That's where this can get a little confusing if you don't remember. So the parties are non-cooperative, so the method must operate without communication between the parties. So there's no dealing, I'll give you this if you give me that. The parties have no knowledge of what the other players like or their valuations. The parties act rationally, meaning they act in their best interest and do not make emotional decisions. And the method should allow the parties to make a fair division without requiring an outside arbitrator or other intervention. So a fair share, when n parties divide something equally, each party's fair share is the amount they are entitled to. As a fraction, it is 1 over n. The 4 classmates are splitting equally a $12 pizza that is half pepperoni and half veggie that someone else bought them. What is each person's fair share? Now, our assumption here is everybody is considered to equally like each thing. So a fair share would essentially be 1 slice of pepperoni, 1 slice of veggie. That's easy. A fair share is an equal share in this case, but that is not always the case. Let's look at some examples where that's not true. So same deal. You have 4 classmates are splitting equally a $12 pizza that is half pepperoni and half veggie. However, Steve likes pepperoni twice as much as veggie. So what would be a fair share for Steve? So we're looking for essentially $3 worth of pizza in Steve's eye, 1/4 of $12. Now, pizza is 8 slices, so there's 4 pepperoni and 4 veggie. Oops. 4 veggie. Now, Steve prefers pepperoni. He likes it twice as much. So essentially, a slice of pepperoni is the equivalent to 2 slices of veggie to Steve. So we can take this, and since there are 4 pepperonis, we take 4 times 2 and we get 8. So the value of 4 pepperonis is 8 veggies, just to get it all in one type of slice. So in Steve's mind, the value of the pizza is 4 plus 8 or 12 slices of veggie. So that means that 1 slice of veggie has a value of $1. 12 divided by 12 is 1. And 1 slice, let me fix that. 1 veggie is worth $1. Now 1 pepperoni is equal to 2 veggies, so it's worth $2. So how do we get $3 worth of pizza for Steve? Well, we could give him 3 veggies, but I don't think he'd like that. We could give him 1 veggie and 1 pepperoni. That would be $3 worth. Or we could give him 1 and 1/2 pepperoni. All in his eyes would be worth the $3 or worth 1/4 the value of the pizza. Any of these would be acceptable. So let's go to Kim. She's another classmate splitting the pizza. She's a vegetarian. She won't eat pepperoni at all. Describe a fair share for Kim. Now, again, we're looking for $3 worth of pizza. And there's 4 pepperoni and there's for veggie. Why do I keep doing that? For veggie. Now, the value of the pepperoni to Kim is 0. It has no value. And don't say, oh, she can take the pepperoni off. Trust me, she'll still taste the pepperoni. So to her, the pizza is really just 4 veggies. So to her, a $12 pizza divided by the 4 veggies, and you get 1 slice is worth $3. So to her, 1 slice of veggie would be equivalent to, would be a fair share in her mind. You see how that's different? Here, for Steve, a fair share to him in veggies would have been 3 slices, whereas Kim, a fair share is 1 slice. So it's all a matter of how that person perceives the value of the pizza. To Kim, the pepperoni slice has to have no value. She doesn't want that pepperoni grease. She don't want that pepperoni. So it has no value to her. Of course, I always thought vegetarians didn't eat cheese either, but we won't discuss that. So now we have some methods to do this. The first method we have is called the divider-chooser method. This is between 2 people. In this method, the divider cuts the item into 2 pieces that are in his eyes equal in value. The chooser selects either of the 2 pieces and the divider receives the other. So you think, okay, just cut it in half. Or if you have 2 items, half and half. And that would work to some degree. But here's where it gets kind of weird. Let's look at this. Let's talk about 2 retirees, Fred and Martha. They get a beach house in Florida together, with the agreement that they will split the year into 2 parts. Fred is chosen to be the divider, and he splits the year into 2 pieces. Now, these 2 pieces in his eyes will be equal. The first piece is November to February, and the other piece is March to October. Now, even though the first piece is only 4 months and the second piece is 8, Fred places equal value on both pieces since he really likes to be in Florida during the winter. Now, Martha gets to pick whichever piece she values more. Suppose she doesn't care. All months are equal. Hey, it's Florida. It's the beach. Maybe she prefers to be there in the summer anyways, but each month is valued the same to her. So of course she would pick the March to October part because hey, that's 8 months as opposed to 4. And everybody would get what they perceive as a fair share. Because Fred split it into what he thought were fair shares. Martha said, hey, if you think this is equal, I'll take the 8 months. Maybe she can stand the cold better. All right, so now we have Dustin and Quinn. We're given an apple pie and a chocolate cake and need to divide them. Dustin values the apple pie at $6. Now we have the pie and the cake. We have Dustin, $6 for the pie, and the cake is $4. Quinn values the apple pie at $4 and the chocolate cake at $10. Describe a fair division if Quinn is dividing and specify which half Dustin will choose. So this gives a value of $14, 4 plus 10. So a fair value would be $7 worth of pie and cake. Now, keep in mind, we said they don't know what the other prefers. Now, there are several different ways this could happen. Quinn could do it the easy way. Half the pie and half the cake. That's a $7 value, right? Half of 4 is 2, half of 10 is 5, $7. That would be the easy way. They have the same amount. However, and it wouldn't matter really which thing he chose. That kind of makes this whole question moot doing this. But let's look at this first. Because doing this, it works out even. Everybody gets half in their eye. But what about this? Maybe Quinn writes the chocolate cake. Maybe Quinn splits it as the whole pie plus 3/10 of the cake. Right? $4 for the pie and 3/10 of the cake is $3. And then 7/10 of the cake. Now this works out well, really, because Destin is probably going to take this half since Destin prefers the pie to the cake, which leaves Quinn with this part, which is what Quinn prefers anyways. So Destin would take this part here if it was split this way. So again, sometimes this works with an even split. Sometimes it don't. You have to keep that in mind. Because what if, well, it would still, no. What if this, well, yeah, what if the pie was $9? Would that still work? 4.5? Yeah, I guess it would. But that's not what we're looking at. So let's just continue on here. Next method is the lone divider method. This is a method for more than two people. So the divider divides the item in n pieces, and we'll label them S1, S2, all the way to Sn. Each of the choosers will separately list which pieces they consider to be a fair share. This is called their declaration or bid. The lists are examined. There are two possibilities. If it is possible to give each party a piece they declare to do so, and the divider gets the remaining piece. If two or more parties both want the same pieces and no others, then give a non-contested piece to the divider. Rest of the pieces are combined and repeat the entire process with the remaining parties. If there are only two parties left, they can use divider and chooser. That'll come up a lot. Once you get down to two people, typically it goes to divider chooser. So let's see. Suppose we have three people splitting a cake. Suppose each person values the three pieces like this. As you can see, the divider has them all evenly. Now here, 1/3 is 33.3%. And here you see the only pieces that chooser 1 and 2 find of a value of 33.3 or more are piece 1. So that means, not that, we have a contested piece. So since both choosers want the same piece, cannot immediately allocate the pieces, the lone divider method specifies that we give a non-contested piece. So the divider would get piece 2 or 3, whichever, didn't matter, he or she valued them at the same amount. And then the other two pieces we put back together, and they would do the divider chooser method from there. So the example says give this to the divider, so you have 70% in chooser 1's eyes and 70% in chooser 2's eyes. So ideally they're going to get at least 35%, which they consider better than a fair share. Okay, so let's use the lone divider method to complete the fair division given the values below. So here we have chooser 1 will accept piece 1 as a fair share, and that's it. Chooser 2 would accept piece 1 or piece 2 as a fair share. Now, while we do have two people that want this piece, chooser 2 is fine with piece 2. as well. So we give chooser 2 piece 2. That means that chooser 1 gets the one they prefer, which is piece 1, and the divider gets the remaining piece, which is piece 3. And it's that simple. Sometimes. I think we got a more complex one here next. So now we're up to 4 people. Abby, Brian, Chris, and Dorian. They're dividing a plot of land. And as you can see, as it mentions, Dorian is the divider. Each person's valuation of the piece is shown below. How would we settle this fairly? So 25% is considered a fair value. Abby is okay with piece 2 and piece 4. Brian is okay with piece 1, 2, and 4. And Chris is okay with piece 2. Now looking at piece 2 here, we see we have 3 people that would like it. But Brian, who wants piece 2, also is happy with piece 1 or piece 4. And Abby, who would like piece 2 or values piece 2 as a fair value, would also like piece 4. So if I give Chris piece 2, that means I have to give Abby piece 4, and then I give Brian piece 1, and that leaves piece 3 for Dorian. And that's the process. So suppose we change the valuations, how would we settle this fairly? So again, Dorian is our divider, 25%. So again, Abby likes piece 2 and piece 4. Brian likes piece 2 and piece 4. And Chris likes piece 2. Now this is a big mess. What could we do here? Well, we could give piece 1 or piece 3 to Dorian. Okay. So let's go ahead and give Dorian piece 1. So this is gone. So now we have 3 pieces left. Now, there's 2 different ways we could do this. We could put those 3 pieces back together, choose a new divider, and start the process over. We could give Chris piece 2 and then use the divider chooser with piece 3 and 4 between Abby and Brian. So there's no shortcut way to do this. I would imagine you'd go with putting the 3 pieces together. The fairest way to do it will be putting the 3 pieces together, picking a new divider, and going from there, which we don't have the information to do. So now we're looking at 4 investors. They're dividing a piece of land valued at $320, $320,000. One was chosen as a divider, and the values of the division in thousands are shown below. Who was the divider? Well, what is a fair share between 4 people for 320,000? 320 divided by 4 is 80. Or, more to the point, who values everything equally? So Cesar is our divider. Okay, so now we're looking for pieces they value at $80 or more, or 80,000 or more. Sonia, we have piece 1, piece 3, and piece 4. Andrea is piece 3 and piece 4. Markel is piece 3 and piece 4. So it looks like Sonia will get piece 1. Since that's the one that's not contested. We'll give Cesar piece 2. And then we have divider chooser, piece 3 plus piece 4, or Adriana and Raquel. So these 2 pieces we put back together, and then they do divider chooser. Next is the last diminisher method. This method, the parties are randomly assigned in order. Maybe pulling names out of a hat. Then we proceed as follows. First person cuts a slice they value as a fair share. Second person examines the piece. They think it's worth less than a fair share, then they pass on the piece unchanged. If they think the piece is worth more than a fair share, they trim off the excess and lay claim to the piece. The trimmings are added back into the to be divided pile. Each remaining person in turn can either pass or trim the piece. After the last person has made their decision, the last person to trim the slice receives it. If no one has modified the slice, then the person who cut it receives it. Whoever receives the piece leaves with their piece, and the process repeats with the remaining people. Continue until 2 people remain, then can divide what is left with the divider chooser method. So what is our example here? Oh yes, this. So we have 4 salespeople that are dividing up Washington State into sales regions. Each will get 1 region to work in. They pull names from a hat and decide the play order. Round 1, the first salesman, Bob, draws a region around Seattle, the most populous area of the state. Piece Bob cuts and automatically lays claim to is shown in yellow. The second salesperson, Henry, felt that this region was worth more than 25%, which is each player's fair share. Because of this, Henry opts to trim this piece. The new piece is shown in pink. The trimmings in yellow return to the to be divided portion of the state. Henry automatically lays claim to the smaller piece since he trimmed it. The third saleswoman, Margot, feels this piece is worth less than 25% and passes, as does the fourth saleswoman, Beth. Since both pass, the last person to trim it, Henry, receives the piece. The second round begins with Bob laying claim to a piece shown again in yellow. Henry already has a piece, so he is out of the process. Margot passes on this piece, feeling it is worth less than a fair share. Now here's where being last can be an advantage. Beth, on the other hand, feels that this piece, as currently drawn, is worth 35%. She's in an advantageous position, being last to make a decision. Even though Beth values this piece at 35%, she can cut a very small amount and still lay claim to it. So Beth barely cuts the piece, resulting in a piece in blue that is essentially worth 35% to her. We'll call it 34 more likely. Since she is the last to trim, she receives the piece. She just trimmed it real thin. At this point, Bob and Margot are the only players without a piece. Since there are 2 of them, they can finish the division using the divider chooser method. Flip a coin and determine that Margot will be the divider. Margot draws a line dividing the remainder of the state into 2 pieces. Bob chooses the eastern piece, leaving Margot with the western half. Notice that in this division, Henry and Margot ended up with pieces that they feel are worth exactly 25%, a fair share. Beth was able to receive a piece that she values as more than a fair share. Bob may feel the piece he received is worth more than 25. So again, it's all about perceptions. So now we get back to a pizza. We have Marcus, Abby, Julian, and Ben. They're splitting the pizza that is 4 slices of cheese and 4 slices of veggie with a total value of 12. Marcus and Ben like both flavors equally. Abby only likes cheese, and Julian likes veggie twice as much as cheese. Divide the pizza using last diminisher method, playing the order Marcus, Abby, Ben, then Julian. I don't really like this question too much, but let's just look at what we can do. So we have Marcus splitting it up. Stop that. So Marcus values everything equally. So essentially, a fair share to him would be 2 slices. Now he could take 2 cheese or 2 veggie, but let's say he likes a little variety, so he goes 1 veggie, 1 cheese. Okay, now when Abby comes around, Abby only likes cheese, so that's not really something she wants, so she passes. Ben likes both flavors equally. So for him to lay claim on this, he would have to skim some off of it. And since it's exactly 25%, if it was me, I would pass. Because if he trims it, it's going to be less than 25%. And then, of course, Julian, who likes veggie more than cheese, would probably pass on it as well. So now this would be Marcus. So next up is Ben. Ben again, same thing. 1 veggie, 1 cheese. Gonna follow the same process essentially. No, it's not Ben next. It's Abby next. Abby only likes cheese, so Abby would probably say, "Hey, let's try this 2 cheese." That's what she likes. It's more than a fair share to her, since the veggie has 0 value, but she might be able to sneak it by. So now Ben again comes up and he's equal. So 2 cheeses is equivalent to 2 pieces. That's exactly 25% to him. So he's going to pass. And then Julian prefers veggie to cheese. So again, Abby's going to get this. So next up is Ben. Ben's equivalent. So maybe he likes the same thing as Marcus. He says, "Hey, cool, I'll take 1 of each, have a little variety." So we give Ben this. And unfortunately, fortunately, actually, because that leaves 2 veggie. 1, 2, 3, 4 cheese, 2 veggies. So there's 2 veggie left for Julian. And this split up actually gives them what they prefer. It don't have to be like this. Maybe Marcus was in the cheese mood, so he hit 2 cheese. Now Abby, looking at it, would she cut it? If it's exactly 25%, 2 slices of cheese, would she cut it and get less than 25 cents? I would think no. So she's going to pass. But there's multiple answers to this like this, which is partly why that type of question is not on the exam or on homework for that matter. I think I'm going to have to make one up because I don't think there's one on here like that. So we have 5 players dividing a $20 cake. In the first round, player 1 makes the initial cut and claims a piece. For each of the remaining players, the value of the current piece, which may have been trimmed at the time it is their turn, is low. Describe the outcome of the first round. So what happens here? Player 1 cuts what he thinks is $4. Player 2 says, "Nah, that's only $3." Player 3 says, "No, that's $5." Now, since player 3 thinks it's more than a fair share, he's going to chop a little bit off and let it go on. And then player 4 and 5 pass. So player 3 gets that slice. So again, now we're in our second round. Player 1 again makes the initial cut, claims a piece, current values are shown, describe the outcome. What happens here? Player 2 says, nah, that's worth $7, cuts a little bit off. Player 4, remember player 3 already has their piece. Player 4 says, no, that's only worth $3 now. Heck with that. And player 5 says, no, it ain't, it's $5. Takes a tiny little sliver off and it goes to player 5. Another method, moving knife method. So in this method, it's applied to a cake. Actually, in the example, it's applied to the steak. A referee starts moving a knife from left to right, although in the case of the example, from top to bottom, across the cake. As soon as the player feels the piece to the left of the knife or above the knife is worth a fair share, they shout stop. The referee then cuts the cake at the current knife position. The player who called stop gets the piece. This procedure continues until there is only one player left and they get the remaining piece. So going back to our 4 salespeople from example 11, decide to use this approach to divide Washington. Rather than move the knife from left to right, they decide to move from top to bottom. Referee starts moving a line down a map of the state. Henry is the first to call stop when a knife is at the position shown, giving him the portion of state above the line. Margot is next to yell stop when a knife is at this position, giving her the second portion. Bob is the next to call stop, leaving Beth with the southernmost portion. And then a method called sealed bids method. You may have heard of this. So this method begins by compiling a list of items to be divided. Then each party involved lists in secret a dollar amount they value each item to be worth. This is their sealed bid. The bids are collected. For each party, the value of all the items is totaled and divided by the number of parties. This defines their fair share. Each item is awarded to the highest bidder. For each party, the value of all items received is totaled. If the value is more than that party's fair share, they pay the difference into a holding pile. If the value is less than that party's fair share, they receive the difference from the holding pile. This ends the initial allocation. In most cases, there will be a surplus or leftover money in the holding pile. The surplus is divided evenly between all the players. This produces the final allocation. So we have Sam and Omar. They have cohabitated for the last 3 years, during which time they'd shared the expense of purchasing several items for their home. Sam has accepted a job in another city, and now they find themselves needing to divide their shared assets. Each records their value of each item as shown below, determine the final allocation so that both Sam and Omar will receive a fair share. So first thing we need to do is add up the values. My calculator is dead. Let's see if I can bring up one. There we go. So we have 150 plus 200 plus 250 plus 50. That's $650. So their share would be $325. Okay, so now I have 100 plus 250 plus 150 plus 100. That's $600. So for Omar, fair share would be 300. So now we allocate the items. And I'm just going to write Sam and Omar. So Sam gets the couch. Omar gets the TV. Sam gets the video game system. And Omar gets the surround sound system. So the couch is 150. Video game system is 250. This has a value of $400. Here we have a value of $350. I didn't remember this working out like this. So what happens here? Sam's got a value that he thinks is $400, but he thinks fair share is $325. So in our holding pile, we put Sam puts in $75. Same thing here. Omar fair share is 300. He gets 350 worth of items. So Omar puts in 50. And nobody gets anything out. So we're looking at minus 75 and minus 50. That's what they've done at this point. Sam got the couch and the video game system and paid $75 in. Omar got the TV and the surround sound system and put $50 in. Now there's nobody to give anything to, so the holding thing has $125 in it. So now we split that with 6250 each, and we add it back in. So Sam gets 6250 back, Omar gets 6250 back. So in total, Sam is out $12.50, and Omar gets $12.50. So Sam has the couch. Sam's final allocation is the couch, video game system, and pays $12.50. Omar has the TV, surround sound system, and receives $12.50. And that is it. Final allocation. And last one, and then we'll have to do one a little different. And we'll go back to the pizza question. So we have Jamal, Maggie, Kendra. They're dividing an estate consisting of a house, vacation home, and small business. Valuations in thousands are shown below. Determine the final allocation. So we have 250, 170, 300, 720. And 1/3 of that is 240. Okay, here we have 300 plus 180 plus 255, 730, oops, 735, which would be 245. And then lastly, we have 280 plus 200 plus 270, which is 750. And we have 250. Okay. So now, who gets what? So let's make notes here. Jamal, Aggie, Kendra. So highest bid on the house is Maggie, 300. So Maggie has the house. Highest bid on the vacation home is Kendra, vacation home. Highest bid on the business is Jamal. So let's look at this. Jamal has the business, which he values at 300,000. Fair share to him is 250, so minus $50. So we add $50 to our holding bond. Maggie received the house, which she values at 300,000. All right, yep. Which is $55 too much, so she pays in 55 plus $55. And Kendra, oh, I messed up. This should be 60, not 50. 240, 300. Kendra received a vacation home worth 2,000. So Kendra is going to get $50. So we're going to take $50 out of this. And everybody's even. Everybody's got their fair share now. And we have left $65. We're going to divide that by 3. And we get $21.67. So now we're going to add 67 to everybody. So that leaves Jamal gets the business and pays $38.33. Maggie gets the house and pays $33.33. And Kendra gets the vacation home and receives $71.67. And that's the final allocation. So let's go back up here to these pizza questions, because amazingly, there's not one similar to the exam question. So let's look at this, and we're gonna for Steve. What is the value of a half pepperoni, half veggie slice? So Steve values veggie is twice as much as pepperoni. So the entire value of the pizza is 12 veggies, like we calculated before. And as we calculated before, one veggie equals $1, and one pepperoni is twice that, which is $2. So if one veggie is $1, one half a slice of veggie is 50 cents. If one pepperoni is $2, one half a pepperoni is $1. So in this case, the half and half price is $1.50. So let's look at Kim here. We have 1/2 pepperoni, 1/2 veggie. Same deal. However, to Kim, 1 pepperoni has a value of 0. 1 veggie has a value of 3. So this slice would be 0 plus 1/2 of 3. 1/2 of veggie would be $1. 3 divided by 2 is 150. So coincidentally, 150. This is the homework problem. This is the exam problem from this, a similar question. Is there another one on here? No, let me change. Okay, nope, everybody's even. So that's it for this chapter. Have a good day.